Imagine the night sky suddenly lighting up with a bright flash. A burning ball appears in the heavens, illuminating the surface of the earth as if it were daytime. But the sun isn't in the sky. It can't be that. There's no roar of impacts, no crackling of the atmosphere, just the eerie howling of dogs who seem to understand, before any human does, that something terrible has happened. Perhaps it's a meteorite or a missile strike. Maybe the magnetic poles have shifted, moving the northern lights to our latitude. Your mind races through possibilities, but one thing is clear. This is a cataclysm on a planetary scale. What to do? One person decides to go outside, away from high-rise buildings, fearing destruction. Someone else seeks shelter in a basement, feeling safer underground. Others frantically try to recall where the nearest bomb shelter is. Amid the confusion, you find yourself on the roof with others, watching the flaming ball in the sky and theorizing about what it could mean. Then someone asks, "Where's the moon?" The realization hits everyone simultaneously. The pulsating fireball lighting up the city is all that remains of our moon. The moon's surface, scarred with countless craters, bears witness to its history of meteor impacts. Without an atmosphere, space bodies strike the moon at full force, perfectly preserved. Meteorites can travel at speeds up to 70 kilometers per second, 70 times faster than a record-breaking jet airplane. A golf ball traveling at such speeds would penetrate about a meter into the lunar soil before exploding, scattering several tons of rock. The impact energy, comparable to 25 kilograms of TNT, would create a small, unremarkable crater. The moon, accustomed to such impacts, would barely notice. But what if we increase the speed? At 300 times the recorded maximum, a golf ball could reach 21,000 kilometers per second, 7% of the speed of light. Such an impact would unleash a force equivalent to the Nagasaki explosion, creating a kilometer-wide crater and triggering lunar earthquakes. Even this, however, wouldn't threaten the moon's existence. To destroy the moon, we'd need to break the laws of physics. Accelerating a golf ball to the speed of light would require infinite energy, as its mass would approach infinity. At 99.99% the speed of light, the ball's energy would exceed 60 megatons, more powerful than the Tsar Bomba, history's largest nuclear explosion. This would split the lunar crust and scatter molten iron from its core, but the moon would remain intact. If we pushed further, the golf ball's energy could surpass 7 billion tons of TNT, rivaling all the nuclear weapons on Earth. The moon's crust would melt, and its core would be exposed, but it still wouldn't be completely destroyed. To achieve total annihilation, we'd need to defy the fundamental laws of physics and imbue the golf ball with infinite energy. Such a ball would pierce through galaxies' black holes and even the moon without slowing down. Upon impact, it would vaporize the lunar crust to a depth of 1,500 kilometers, reaching the core in seconds. The moon would disintegrate, its matter turn to high-temperature plasma that would flood the solar system with light and radiation. Standing on Earth, we'd watch the fiery aftermath, surrounded by confusion and horror. The moon's remnants would cool, forming an asteroid belt that would orbit Earth. Over time, some of these asteroids might strike the planet, but our atmosphere would protect us, as it has for billions of years. The destruction of the moon would transform life on Earth. Tides would vanish, tidal power plants would become obsolete, and the night sky would grow darker, revealing countless stars previously hidden. Humanity would adapt, but the absence of the moon, a celestial companion that has inspired travelers, lovers, and dreamers for generations, would leave a profound void. How would civilization change in the wake of such an event? Let us know your thoughts.